Let's take a look at week 10, example 6. In this example, we're being asked to solve the equation cosine of 5x equals 1/2. And we're looking for solutions that are within the interval 0 to 180. This gives us a couple pieces of information. One, I can tell that we're not looking for our general solution in terms of k, but rather a particular list of solutions that only exist within the interval 0 to 180. Second, I can see that since my upper bound for my interval is 180, I know that we're going to think in terms of degrees for this problem, not radians. Thinking about our equation here, what's certainly going to be the hairiest part of this equation is dealing with this 5. And so what I'm actually going to do for my first step is I'm going to make a little swap that's going to prevent me from having to think about the 5 until I've actually done all my trigonometry thoughts here. The first thing that I'd like to do here, and in general, anytime I have some less comfortable statement within my trig function here, I very often make this change of variables to simplify the statement that I'm looking at to get started. In this case, what I'd like to recognize is that we are taking the cosine of some angle. 5x is the angle, not just x. 5x is the angle that we are applying the cosine function to get out and output a width of 1/2 here. So I'm going to indicate exactly that idea. Since 5x is the angle that we are applying the cosine function to, I'm going to change variables. I'm going to create a new variable, theta, and theta is going to be the angle, 5x. This is going to allow me to rewrite our equation as cosine of theta equals 1/2. So on the one hand, we've changed our equation from something a little bit difficult to handle to something much easier. But what we've also done is we've added an extra step for ourselves. Since we've swapped ourselves out from x information to theta information, at the end of this problem, we're going to have to swap back from theta back into x, because x is how we actually want to describe our solutions. The good news is, though, I can now use this idea of our theta equation here to help me think about the unit circle that should be associated with this equation here. So in my unit circle, I am interested in finding all angles that will result in a width of positive 1/2. In my unit circle, I can see these two angles appear to be the ones that I'm interested in here. Hopefully we recognize these as 60 degrees for the top one. If I've opened up 60 for the first, then I should be opening down 60 for the second. It wouldn't be wrong to call this negative 60 degrees then, but I typically like to list my angles, at least my initial angles, as a 0 to 360. And so rather than saying negative 60 degrees, I'll reference this as a positive 300 degrees. So it seems like 60 degrees and 300 degrees are the two angles that will make this equation true. You should notice that 300 is certainly not within our desired interval, but you should also notice 360 here are theta angles. We need to make sure that x is within 0 to 180, not necessarily theta. So we'll make sure that we're within this interval at the end of our problem here, but for right now, let's kind of remain general for right now to make sure that we find all the possible parts here. So as we did in the previous problem, we should now be able to state some general solutions that are associated with this equation, knowing our base angles that we're going to work from. I can make my statements that this should be theta equals 60 plus 360k. That's one of my general solutions. My other general solution part is going to be 300 plus 360k. But again, not only are we not interested in general solutions, we're interested in particular solutions. We're also not interested in solutions for theta. We're interested in solutions for x. So we still have two small adjustments we need to make, but we've at least set ourselves up with an environment to which we can get at those answers. The first thing I'm going to do is I'm going to switch back from theta into x, and I have a very easy way to do that. We set up for ourselves this change of variables equation, theta equals 5x, and so I can replace theta with 5x in both of these cases here. Theta is the same thing as 5x. Our goal is to find x, not 5x, so my first algebraic move is going to be to divide by 5 on both sides. That's going to leave me with 60 divided by 5 is 12. 360 divided by 5 is 72. For our other equation, we're going to get x equals 60 plus 72k. So these now represent my general solution. What I am not interested though necessarily is my general solution. If this said find the general solution to this equation, we'd be done. Put a box around those two guys there. But what we are interested in is just the ones that land within 0 to 180 based on these two equations here. So I'm going to give myself a little bit more room, and let's go ahead and identify for ourselves what are the particular solutions that we are interested in here. So our first set of solutions comes from the general equation 12 plus 72k. Our second set of general solutions comes from the equation 60 plus 72k. And what I'm going to do is I'm just going to choose the values of k that are going to get me within 0 to 180 here. We want to remember that k is an integer. Integers can be positive or negative. So typically I like to think from left to right. And when I think left on the number line, I think negative values. So the first question I want to ask myself is, are there any negative values of k that I need to consider here? Well, even if I pick k equals -1, it looks like if k is -1, we'll get -60 here. That's not part of my desired range. If I do k as -1 here, we'll get -12, which is closer, but still not within our desired range here. So it doesn't look like using negative values for k in this case is going to be useful for us, but depending on the span that we've been given, depending on the format of our general equations, it might be the case that you might be using negative values for k, just not in this particular example. The next question that I would then ask, if I know that I'm not going to use negatives on the left, maybe 0 and then positives. So I'm going to ask myself, what happens if I choose a k value of 0? Well, if k is going to be 0, maybe I'll make myself a table here. If my k value is 0, then I can see that I'm going to get a value of x equals 12. And we should notice 12 is certainly within our desired span here, so it looks like 12 actually will be one of our solutions. Similarly over here, we'll get 60 when we use k as 0. This says don't do any additional laps, just be at your original locations. And you should notice that 12 and 60 are both 60 and 300 divided by 5 is where those values came from. Now we'll say, okay, maybe there's some more solutions out there that still live within our desired interval. Let's go ahead and say, if you do one additional revolution, could you still land at some values that solve this equation are within that interval? If we allow k to be equal to 1, we should find that x is going to be 12 plus 72 will give me 84. Similarly on the other side, 60 plus 72 will give me 132. And again, I'm noticing that both of these solutions are within our desired interval, so it looks like they'll be kept as part of the solution set as well. Let's keep looking. If I say k equals 2, if we're allowed multiple additional laps, 2 additional laps here, then 2 times k should be 144, 154, 156 for x. And similarly over here, if I let k be 2, we're going to get 144 plus 60 gives me 204. Now, we should notice that while 156 does lie within our desired interval, 204 does not. So it looks like we've gone a little bit too far here. We can additionally see that if I choose values like k equals 3 or larger, we're going to keep on getting larger and larger angles out here, none of which will fall within our desired interval. So I'm going to maybe go ahead and put a line through that guy right there. It's true, this should be part of maybe a general solution or maybe a broader interval, but since it doesn't fall within 0 to 180, we're not interested in that value there. So it looks like we've probably found all of our solutions here. We considered negative k's and they didn't work. We always otherwise would start at k equals 0, and then we looked at positive k's until they got too large for us to land back in our interval. So I'm pretty confident that I've checked all the possible values we need to consider, and I might state my formal final solution here as x equals. Remember that whenever we're giving a whole collection of numbers to indicate lists mathematically, we use curly braces. So I'm going to open a set of braces to say a list of values. What list of values represent the solution set for x? Well, I'm just going to list them in order here. It looks like 12 degrees, 60 degrees, 84 degrees, 132 degrees, and 156 degrees should be the representative solutions within this interval to this equation. Finally, I would like to suggest that you graphically verify this. If you go to Desmos, then you should enter in y equals cosine of 5x as your first equation. You should enter in y equals 1/2 as your second equation, and you should look for all the intersections between your cosine graph and your horizontal line at 1/2. You should find 5 intersections from 0 to 180, and it should be at exactly these degree angles right here.